Let's now dive deeper into the components that make all of this possible. MCP is structured around some major roles like host, client, server, tools, prompt, and resources. Let's start with the client. The client is a starting point. It is the part of the system that receives user instructions or goals and sends them into the MCP world. It doesn't care how the job gets done, it just knows what needs to happen. Think of it as the user facing interface, like a chatbot or a voice assistant. For instance, you might say, summarize this document. That request is a client's job to pass forward. So, in short, the client sends the user's goal into the system but doesn't manage the internal steps. Now comes to the host, which is arguably the most critical piece. The host is the brain of the system. It receives the message from the client, interprets the intent, and then decides how to break the task into subtasks. Let's say the task is to summarize a PDF. The host will figure out which tool can read the document, which tool can generate a summary, which server can carry out the task, what memory tools and resources are already in use. The host also maintains shared context, meaning it tracks memory across steps and manages all resources and tools involved. In a sense, the host is the smart coordinator, routing each subtask to the right server while ensuring everything remains in sync. Finally, we have the server. The server is where the actual work happens. It performs the task assigned by the host. This could be an AI model, an external API, or a dedicated tool, anything with the capability to act on data or produce results. For example, a server might be a code interpreter running Python code, a model accessing the web, an agent querying a SQL database. So, if the client says, give me the weather in Manali, the host routes the request, the server then accesses a weather API and return the results. You can think of the server as the worker, the one that executes the logic and delivers the outcomes. Alongside these structural components, MCP also defines how models interact with the world through tools, prompt, resources. Tools are actionable interfaces, for example, a calculator tool, an SQL engine, or a web scraper. All of these can be tools under MCP. MCP tools refer to executable functions that AI agents can use to interact with external systems and data sources, enabling actions like API calls, database access, or file operations. Here you can see an example of tool. The only difference from a normal function is that an MCP tools require a top level description. Here we use the decorator @mcp.tool. This is a decorator. The first tool to calculate the BMI. This tool is used to calculate the body mass index. Second tool is making an API call and returning the response of the weather API. MCP resources. These are passive these are passive assets, files, documents, databases, or repositories that tools can use. They do not perform actions, but they support actions. With the help of resources, we can provide additional information to the LLM. So this resource is an example of a static resource, and second one is an example of dynamic resource. Here we are providing user ID to the tool as in resource. And just to be clear, tools are doers, resources are helpers, and prompts are the instructors. This slide visually compares tools and resources to reinforce this concept. The features, MCP tools and MCP resources are the column name. And what is the purpose of MCP tools is to perform actions, and the purpose of MCP resource is to provide data. And REST API equivalent, MCP tools can use post, put, delete, and the MCP resource can use get API. Use cases are like for the MCP tools is to sending an email, booking a meeting, and so on. So in the MCP resources, here we can see like fetch user profile, config metadata, and etc.